Welcome. Today, we write a JavaScript program that can find the kth smallest number in an m times n multiplication table. Instead of building the full table explicitly, we'll use a smart binary search approach to keep it efficient. This method is very useful for large tables where constructing every element would be too slow. Let's dive in and see how it works step by step. In a multiplication table, each cell is simply the product of its row and column indices. The task is to find the kth smallest number efficiently. For example, in a 3 by 3 table, the sorted elements are 1, 2, 2, 3, 3, 4, 6, 6, and 9. The eighth smallest is 6, which we want our program to compute without generating an entire table manually. We first validate that k is within range. Then, we perform a binary search on possible values from 1 to m times n. For each midpoint, we count how many numbers in the table are less than or equal to the mid. If the count is greater than or equal to k, we move the search left. Otherwise, we move right. Finally, the lower bound s gives the kth smallest number. We perform binary search over all possible values. At each mid, we calculate how many numbers in the multiplication tables are less than or equal to mid. Based on that count, we shift the search range left or right. When the search finishes, the lower bound gives us our answer efficiently without generating the full table. Here are some examples. In a 3 by 3 table with k being 8, the sorted elements gives 6 as the 8th smallest. In a 2 by 3 table with k being 4, the result is 3. This shows the method works for varying sizes and k values. Counting without constructing large tables is crucial in programming and data analysis. Binary search over possible values helps solve problems efficiently. This technique is often seen in competitive programming, algorithm exercises, and database optimization. By, by combining binary search with element counting, we efficiently find the kth smallest element in any multiplication table. This approach avoids large memory usage and scales well. It is a perfect example of optimizing algorithms using math and JavaScript logic. Thanks for watching, and happy coding! Thank you for watching. If you enjoyed this video, please make sure to like and subscribe for more JavaScript tutorials. I'll see you in the next one.